Hello and welcome to the video tutorial series by LearnBiz Simulations. In this module, we will teach you some of the mechanisms to do what-if analysis in Excel. We will cover the following topics in this video: Scenario Manager, Goal Seek, and the Excel Solver. MS Excel is used to perform what is commonly known as what-if analysis. What-if analysis examines how sensitively a situation will react to changes in factors that influence the situation. Some of the methods used for what-if analysis are given below. Data type, this is already covered in the previous topics. Scenario manager, goal seek, finally Excel solver. Excel enables you to create and save sets of input values that produce different results as scenarios with the scenario manager option. A scenario consists of a group of input values in a worksheet to which you assign a name such as best case, worst case, most likely case, and so on. This helps us to reuse the input data of the scenario and view the results that they produce in the worksheet. Using a scenario involves the following: creating a scenario, viewing a scenario, producing the result as a summary report. Let's look at an example. You might want to compare best case and worst case scenarios for sales in a coffee shop based on the number of cups of coffee sold in a week. So, scenario requires two things: changing or variable sales that change in each scenario, and dependent scenario formula on this variable cells. In this case, the changing cells are the sales figures of the cups, and the dependent scenario formula is the revenue calculation from these changing cells. To create a scenario, click on Scenario Manager in the Data tab under What If Analysis group. The Scenario Manager dialog box opens. Click the Add button to create your first scenario. Type best case or any other suitable name in the scenario name box. In the changing cells box, specify the variable cells that you want to modify in your scenario. Hold down the control key while you click on them, that is cells B7, B11 and B15. Click the OK button in the Add Scenario dialog box to add your scenario to the scenario manager. You will see scenario values dialog box which asks the values of changing variables corresponding to this scenario. Type 150, 225 and then 125 for best case. Click the Add button in the Scenario dialog box to return to the Add Scenario dialog box where you will create a second scenario, say worst case, with values 50, 40 and 30. The Scenario Manager dialog box lists the best case, worst case scenarios that you have just created. Click the Close button to close the Scenario Manager dialog box. Viewing a scenario involves viewing the result when each scenario is applied to the worksheet. To view a scenario, open the Scenario Manager dialog box in the Scenarios list, click the scenario that you want to view and click the Show button. The Excel will substitute the values in the scenario for the variables on your worksheet and display the results on your worksheet. Select additional scenarios and click the Show button to compare and contrast the various what-if models on your worksheet. When you are finished, click the Close button to close the scenario dialog box. Creating scenario reports. You might occasionally want to view a report that contains consolidated information about the scenarios on your worksheet. This can be accomplished using the scenario report. To create a scenario report, open the Scenario Manager dialog box, click the Summary button to open the Scenario Summary dialog box. The Scenario Summary dialog box prompts you for a result cell to, to total in the report and also for a report type. A scenario summary report is for formatted table that appears on its own worksheet. A pivot table report is the special summary table whose rows and columns can be rearranged or pivoted. Select the result cells that you want to total, cell E6 in this example. Click the report option button that you want to use and then click the OK button. After a short pause, a new scenario summary tab will appear in the workbook as shown. Next is goal seek. Sometimes you know the outcome that you want to realize in a worksheet and you need Excel to help you find the input values necessary to achieve those results. This procedure, which is just the opposite of the what if analysis, is referred to as goal seeking. Goal seek command can be used to find the value for a single variable that will give the desired result. For example, we need to determine the number of cups of coffee priced at rupees 1.75 that you would have to sell to gross rupees 30,000. To use goal seek, set up your worksheet to contain the following: a formula that calculates your goal. Here it is the formula for the sales revenue. An empty variable cell for the unknown number that will produce the desired outcome. Here it is the number of cups of coffee to reach the target. Values in any cells other than the empty cell that the formula refers to. Here it is price of 1 cup. First, select the cell containing the formula, then click on Goal Seek in the Data tab under What If Analysis group. The Goal Seek dialog box opens. First, select the set cell to the formula cell and then type the goal that you want to reach in the value box. So to reach 30,000 in sales, type 30,000 in the to value box. Then set the by changing cell text box to the blank cell, that is to contain your answer, that is the variable cell. Click the OK button to find the solution for your sales goals. When the goal sheet command starts to run, it repeatedly tries new values in the variable cell to find a solution to the problem you have set. This process is called iteration and it continues until Excel has run the problem 100 times or has found an answer within 0.001 of the target value you specified. Because it calculates so fast, the goal sheet command can save you significant time and effort over the brute force method of trying one number after another in the formula. Excel will display the goal seek status dialog box when the iteration is complete and the result of your forecast will appear in the worksheet. This forecast shows that you need to sell 17,143 coffees at rupees 1.75 per cup to reach your sales goal of rupees 30,000. Goal seek is simple because it can calculate only one unknown value. But when you need to perform more complex goal seeking, such as that which involves changing multiple input values to realize a result or constraining the value to specific range, you can use the solver. Let's continue the previous example in which we were running a coffee shop that currently sells three beverages and their prices are given. But we are not sure what our revenue potential is and what emphasis we should give to each of the beverages. Let's solve this problem using the solver add-in. Note that Solver is an add-in utility and can be found in the Data tab in Analysis group. If it is not installed, the same can be added using options in File menu and clicking on Add-ins and activating the Solver add-in. First, we need to set up the problem in our worksheet by defining the following items. Target cell. The cell in your worksheet whose value is to be maximized, minimized or made to reach a particular value. In this case, we need to maximize our revenue for the week. Changing cells. The cells in your worksheet whose values are to be adjusted until the answer are found. In this case, it is the number of cups of each coffee we need to sell. Constraints. The limits that you impose on the changing values or the target cells. For example, in this case, we are currently able to produce only 500 cups of coffee per week, cafe mochas to 125 per week, and premium coffee drinks to 350 per week. So your worksheet should contain cells that calculate the values such as used as constraints, which we have done. After the setup, to solve the problem, click the target cells you want the solver to determine. In our example, it is E6. Next, open the solver by clicking in the solver add-in in the analysis group of the data tab. The solver parameter dialog box will open. Click the max option because you want to find the maximum value of the target cell in this case. In the changing cells box, specify the variable cells that you want to modify. Hold down the control key while you click on them, and that is cells B8, B12 and B16. Constraints aren't required in all solver problems, but this problem has three. Click the add button to add the first constraint using the add constraint dialog box. Similarly, define the other two constraints. To modify one of the constraints that appear in the solver parameters dialog box, select the constraint and click the change button. By default, the solver add-in employs the GRG non-linear method in solving the model, which is an efficient way to solve smooth non-linear problems. You can use the LP simplex method or evolutionary engine for solving non-smooth problems. Your forecasting problem is ready to go, so click the solve button to calculate the result. After a brief pause, the solver will display the solver results dialog box describing how the optimization analysis went. If the solver runs into a problem, you will see an error message and you can click the help button to learn more about the difficulty. To display the new solution in your worksheet, select the keep solver solution option in the solver result dialog box and then click the OK button. So we have learned that if you are limited to selling 500 cups of coffee per week, you can expect a maximum of rupees 918.75 in revenue and your optimum drink distribution is 150 cups of regular coffee, 225 of cafe latte and 125 cups of coffee mocha. But what if there is more than one solution to the problem? The solver simply starts with the current numbers in the variable cells and adjusts them until it found an acceptable solution, subject to the constraint described in the previous example. This is why if you use different starting values in the variable cells before you run the solver, you can get different results from a problem with multiple solutions. and hence it is advisable to run solver multiple times with different initial value. But what if solver reaches its iteration limit without finding a solution? The starting values in the variable cells can affect the solution. Solver might fail to find a solution or it might time out before reaching a solution. Try adjusting the starting values and restart or click continue to use the maximum solution time. You can adjust both maximum iterations and maximum time by using the option buttons in the solver parameters dialog box. That's it in this video. We'll continue our Excel video tutorial series in the next video. Thanks for watching. You may visit our website www.learnbizsimulations.com to check out some of our business simulation games for learning and assessment.